Today we're going to solve for variables when they're stuck inside absolute value symbols, and we're going to look at what those solutions look like on the graph.
Absolute value is something you've seen before, but let's go over exactly what it means. Absolute value is the distance a number is away from zero, okay? So let's look at kind of an example here. If we say the absolute value of x is equal to 3, okay, we can draw a number line. So here's 0, and if we go 1, 2, 3 to the right, we would get to 3, and then 1, 2, 3 to the left, we would get to negative 3. So if I go 1, 2, 3, that's 3 spots away from 0. And same here, 1, 2, 3, that's also 3 spots away from 0. So in this case, the absolute value of x, when it's equal to 3, that means x could be negative 3, and x can be equal to positive 3, because both of these are 3 spaces away from 0. Another case that we could look at is, let me switch back to white, if we have the absolute value of x is equal to negative 4, okay? So if we draw a number line, we've got 0, and we go 1, 2, 3, 4, and 1, 2, 3, 4, okay? We're saying here that the distance x is away from 0 is negative 4 spaces. But if we were counting, we would go 1, 2, 3, 4. That's positive 4 spaces. And 1, 2, 3, 4, that's also positive 4 spaces. Okay? So what we say is that this has no solution. Okay? And so we remember that absolute value cannot be negative. Okay, we're always looking for the positive value when we're dealing with absolute value. Let's go over a couple examples. So here we have the absolute value of x minus 9 is equal to 5. So that means if we were on a number line, here's 0. If we go x minus 9 places, we're going to get to 5, and we're going to get to negative 5, right? And so we want to find out what x is. And so what we're going to do, just like how we did up here, we basically have two equations we're trying to solve. We want to see where x minus 9 is equal to negative 5, and we want to see where x minus 9 is equal to positive 5. Okay, so now we just solve this one-step equation. We can move this 9 over and move the 9 over, so that's going to be a plus 9 on both sides. And so 9 minus 5 is going to get us x is equal to 4. And on the right side, we've got 5 plus 9, so x is going to be equal to 14. And whenever we have two solutions like this, we usually like to write it in a set, which is just x equals the squiggly bracket. We write our lower number first, which is 4, and then our bigger number, which is 14. Okay, and now I'd like to take a second to show you exactly what this looks like on the graph. So we're working with functions which are going to make a graph. So if I separate this out into two equations, I'm going to say y equals the left-hand side, which is the absolute value of x minus 9. We get this V-shaped graph here, which we'll talk about more in our next unit. But now if I type in my y equals the right side, which is 5, I get this blue line that goes right across through this V shape. And if I click on these 2 points here, I see that this blue line crosses the red graph at x equals 4 and at x equals 14. So those solutions are exactly where the line and the absolute value graph meet. Let's do another example. Here, we've got some junk going on outside my absolute value. So let's get it just so that it looks like this one and clear out everything that's attached to the absolute value. We want to do this in reverse PEMDAS order. So I see that this 9 is being subtracted to this 4, which is being multiplied. So if we think in reverse PEMDAS order, we're going to start with whatever's being added or subtracted. So I'm going to take this 9, and I'm going to move it to the other side. And when I do that, I get a negative 9. So I've got negative 4 times the absolute value of c plus 10 is equal to negative 15 minus 9 would get me negative 24. And now this negative 4 is being multiplied to my absolute value. So I'm going to divide by negative 4 so that I get the absolute value of c plus 10 is equal to negative 24 divided by negative 4 will get me a positive 6. And so now I know that this is going to look like we've got 0, 6, and negative 6, and both of those are going to be c plus 10 spots away. So I've got c plus 10 is equal to negative 6, and c plus 10 is equal to positive 6. So now to solve, I'm just going to take my 10 and move it over, and it's going to become negative. So I'm going to get c is equal to negative 16, and c is equal to negative 4. And so I'll put these as a set now. I'm going to look at negative 16 and negative 4. Now let's check this in the graph. I'm going to type in my left side. So I'm doing y equals 9 minus 4 times the absolute value of c plus 10, and I get this upside down v. And then I'm going to say y is equal to negative 15 to get this purple line. And I see that they're equal at negative 16 and at negative 4.
Now let's talk about some special cases whenever we're solving absolute value equations. So our next example will be this. So let's keep doing what we have been doing and try and get the absolute value by itself. So first I'm going to take this positive 9 and move it to the other side since I'm moving whatever is adding or subtracting first. So I get 3 times the absolute value of 2x minus 4 is equal to 9 minus 9 is 0. Then I can divide by 3 to get the absolute value of 2x minus 4 is equal to 0 minus 3 is still 0. And so I get the absolute value is equal to 0. Now 0 is not positive or negative, so when we do this, we only have to do one equation. I just have 2x minus 4 is equal to 0. And so I can take my 4 and move it over to be plus 4. So I get 2x is equal to 4. And then if I divide by 2, I get x is equal to 2. And so now what this looks like on the graph is if we say y equals 3 times 2x minus 4 and then plus 9, I get this blue v. And then if I say y is equal to 9, I see that the green line only touches the blue graph at one point, and that point is at x equals 2. We're going to do one more problem now. So let's get the absolute value by itself. I have this plus 8. I'll move it to the other side and say minus 8. To get 3x minus 2 is equal to 1 minus 8 would give me negative 7. Now, if we think back to the very beginning of this lesson, we said that the absolute value of anything cannot be a negative number. And so when we get this absolute value is equal to a negative number, we say that it has no solution. And what that looks like on the graph, if we type this in, we have y equals the absolute value of 3x minus 2 plus 8, and then we have y is equal to 1. That black line never touches that purple graph anywhere, so we have no solution. And this has been our lesson over solving absolute value equations. I hope you had as much fun as I did, and I'll see you in the next video.